Hey guys, so we're going to take a look at graphs of inverses, and we have a table of points, so that we're going to start off by plotting the points from table 1 on the graph over here. So I think we already know how to do that. Now to find the inverse points, we're going to switch the x and y coordinates. This is very important that you memorize this, that in order to find the inverse, you switch the x and the y. So our inverse points are going to be switching the original points. And when we graph these points and draw the line, and we plot these points and draw the line, we'll have our two inverse functions. Now I'm not going to do that because I know that 6th and 7th period did not get graphs. So 6th and 7th period, I expect you to write down the examples, the two tables, and then go ahead and write the inverse points here of this table. Okay? That's pretty easy. Let's keep moving forward then, because we've kind of covered that in the last video. When two graphs are reflections of each other over the line y equals x, memorize that, then they are said to be inverses to each other. To find the equation of the inverse, notice anytime I put a star, this is important. Switch the x and y in the equation and solve for y. So if I want to find the inverse equation, we switch the x and the y. Nothing else moves, only the x and the y. And then we solve for y. Remember, when solving for a letter, we undo adding and subtracting first. Many people did not do that on the test yesterday. And then we undo multiplying and dividing next. Okay, now when writing the inverse, we're going to write the letter, and then this is inverse notation, the -1. This is inverse notation, need to know that. Equals, and I'm going to go ahead and break this up into 2. So this is going to be 1/4 x, and then -8 or -8 divided by 4 is -2. So that is our inverse equation. Another way to write inverse besides the -1 on the y is to use function notation, and that looks like that. Okay, so number 4, your turn. Number 5, so we're going to switch the x and the y. Now the reason I'm doing this one, notice, is because the original was quadratic. So these both were linear functions. So solving for y, we're going to undo adding and subtracting first, which many of us forgot to do on our absolute value equations. Then we undo multiplying with division. I'm going to go ahead and break this up. So this is going to be 1/8 x. 8 divided by 8 is 1. And then finally, we need to get rid of the square. The inverse or the opposite of squaring is square rooting. So to undo the square, we're going to square root both sides. Okay? So what happens is the square and the square root cancel out. And now we have our inverse function. So notice that the inverse of a quadratic is a square root function. Okay, it says write the equation of the inverse. We know how to do that. Then graph the following relation and its inverse on the same set of axes. We're not going to do that. We already know how to do that. Let's take a look at number 7. Let's start off by graphing it. So this is going to be a parabola. That's been translated 1 unit up, so 1 up. The A value is 1, so we're going to go over 1 and up 1, over 1 and up 1. So notice I got my 3 points here. You could get more points off of your calculator or Desmos. Now that we have those, let's go ahead. It says write the equation of the inverse. So let's go ahead and switch the x and the y. Solve for y. Undo adding and subtracting first. We undo squaring with square rooting to cancel it out. So our inverse function is going to be, don't forget the -1 for inverse, is the square root of x minus 1. So we have a square root function that's been shifted 1 unit to the right. So if I go over here and I go 1 unit to the right, that's going to be my starting point. And to get the other points, now I haven't taught you how to get the other points, but we could just switch these points around. So this is going to be -1, 2. So our inverse point is going to be 2, -1. This point's 1, 2. So our inverse point is 2, 1. So notice. And then if I draw my line of reflection, it goes right in between. Line of reflection, or line of symmetry. You're not going to believe what that bell means. That means it's time for 6th period. But before we do that, let's answer these questions. Is the relation, in other words, is the original here, this a function? And of course, it passes the vertical line test, so yes. Is the inverse a function? Well, if I draw a vertical line, it touches it in 2 places, so no. Now, I know that some of you don't have graphs at home, so you're going to have to sketch this by hand. Sorry about that. And you don't have to do 8 on the back. Have a great night. See you guys tomorrow.